Hello everyone. Today we are going to analyze this fixed beam. In this beam there are 2-point loads 18 kN and 9 kN. The load 18 kN is acting at a distance of 2 meter from the point A. The load 9 kN is acting at a distance of 4 meter from the point A. The total length of the beam is 6 meter. Now we are going to find the fixed end moments in the points A and B. We are going to use the formulas to find the moments. If the fixed beam is subjected to an eccentric point load, the formulas to find the fixed end moments are WAB square upon L square and WAB square upon L square. First, let us take this point load. For that load, let us use these two formulas. Here W is 18, A is 2, B is 4 and L is 6. Now let us take this load. For that load let us use these two formulas. Here W is 9, A is 4, B is 2 and L is 6. After adding these two, we will get 20 kilonewton meter, and after adding these two, we will get 16 kilonewton meter. We know that the movement in the point A will be acting in the anti-clockwise direction, and the movement in the point B will be acting in the clockwise direction. We have calculated MA and MB. Now we are going to find the vertical reactions RA and RB. First, let us find RA. For that, I am going to take movement about B. In this case, I am moving towards right hand side. Clockwise will be positive and anti-clockwise will be negative. MA is acting in the anti-clockwise direction, so that it will be negative. RA is acting in the clockwise direction, so that it will be positive, and the distance is 6. So 6 RA. This load is acting in the anti-clockwise direction, so that it will be negative, and the distance is 4 meter. This load is also acting in the anti-clockwise direction, so that it is also negative, and the distance is 2. MB is acting in the clockwise direction, so that it will be positive. Finally, for RA, we are getting 15.667 kilonewton. Now let us apply the rule sigma V is equal to 0 and find RB. RA and RB are acting upwards, so both of them are positive. These two loads are acting downwards, so both of them are negative. Finally, for RB, we are getting 11.333 kilonewton. Now we are going to draw the shear force diagram. I'm going to find the shear force values from the point A and towards the point B. In this case, I am moving towards right hand side. Upwards will be positive and downwards will be negative. Using that rule, we can find the shear force values. Here you can see the shear force diagram. Now we are going to draw the bending moment diagram. Let us use the superposition method. In this method, first we have to consider the fixed beam as a simply supported beam. You can see that I have converted the fixed beam into a simply supported beam. Let us find the reactions RA and RB. Let us take moment about B and find RA. In this case, we have to use right hand side rule, clockwise positive and anti-clockwise negative. RA is acting in the clockwise direction, so that it will be positive, and the distance is 6, so 6 RA. This load is acting in the anti-clockwise direction, so that it will be negative, and the distance is 4. This load is also acting in the anti-clockwise direction, so it is also negative, and the distance is 2. Finally, for RA, we are getting 15 kilonewton. By applying the rule sigma V is equal to 0, we can find RB, which is 12 kilonewton. For the simply supported beam, now let us draw the bending moment diagram. To find the bending moment in the point C, we have to multiply RA with the distance 2. 15 into 2, we will get 30. To find the bending moment in the point D, we have to multiply RB with the distance 12 into 2, we will get 24. Then we can connect the points. This diagram is called the free movement diagram. Now, using the end movements, we can draw the end movement diagram. For MA, we have got 20, and for MB, we have got 16. Now, let us combine both of the diagrams so that we will get the bending moment diagram. Alternatively, we can draw the bending moment diagram in only one step. For that, we have to find the bending moments in every points separately. To find the bending moments in the points A and C, we can use right hand side rule. Clockwise will be positive and anti-clockwise will be negative. Let us find the bending moment at A. In the point A, we have MA, which is acting in the anti-clockwise direction, so that it will be negative. Let us find the bending moment in the point C. MA is acting in the anti-clockwise direction, so that it will be negative. RA is acting in the clockwise direction, so that it will be positive and the distance is 2. For the bending moment at C, we are getting 11.33 kilonewton meter. To find the bending moments in the points B and D, we can use left hand side rule. Clockwise will be negative and anti-clockwise will be positive. Let us find the bending moment in the point B. In the point B, we have MB, which is acting in the clockwise direction, so that it will be negative. Let us find the bending moment in the point D. MB is acting in the clockwise direction, so that it will be negative. The vertical reaction RB is acting in the anti-clockwise direction, so that it will be positive and the distance is 2. Finally, for the bending moment at D, we are getting 6.67. Here you can see the bending moment diagram. In these 2 points, the bending moment becomes 0. Let us make sections in both of the points. I have made this section at a distance of x from the point A, and I have made this section at a distance of x from the point B. We know that in this section the bending moment is 0. Using the right hand side rule, we can find x, which is 1.27 meter. We know that in this section also the bending moment is 0. Using the left hand side rule, we can find x, which is 1.41 meter. Now we are going to end this session. Thank you for watching this video.